Okay, so let's try to code this up. Okay, so first we'll check whether the total sum is greater than target or not. Okay, if it is less than, then we cannot reach target, right? So what we can do, so we can say total sum is equal to sum of nums. Okay, and if target is greater than total sum, if target greater than total sum, then return 0, we cannot reach target. Okay, so over here we have to do an absolute operation over here, because it is says like target can be negative also. So in that case we can say abs of target is greater than total sum. Then as we discussed before, like either we can take -1 or we can take +1, right? So we need to make choices over here. So in that case what we can do, like we can have a DFS, typical knapsack problem. Okay, where we can have an index, so two parameters, index and current target. Okay, and base case will write later. Okay, then we'll have two cases. Okay, so choice 1 and choice 2, right? So choice 1 is like we'll be taking +1, and choice 2 is we'll be taking -1. Okay, so in that case we can say like return DFS of index +1, current target plus nums of index. So we are taking plus over here, nums of index. So this is choice 1, and we need to return the count, right? So we need to return the number of ways. Then we need to add one more choice over here. So in this case DFS of, we'll copy this. Okay, and over here we will mention -1. Okay, so this is done. Okay, and then we will write the base case over here. So base case would be if index we have reached at the end, if index is the nums of length of the nums, then we can say return 1 if current target becomes 0. If current target becomes 0, then return 1, else 0. Okay, and finally we can call this function return DFS. Index will be 0, and target, we can pass the target over here. Okay, let's try to run this. Okay, it's passing. If we submit this, I think we'll get a TLE, so better not to submit. Okay, so what would be the time complexity for this? So time complexity would be as you are making choices, two choices at certain state, at certain stage. So time complexity would be 2 to the power n. Space complexity would be the auxiliary stack space, because we are using a recursion over here, so it will be O of n. Okay, now if how can you optimize this? So if you want to optimize, then we can take memoization. Okay, so in Python, I mean, we can quickly do it. So we can take help of LRU cache, just 2 lines of code we can add. Okay, so from functools import LRU cache. Okay, and over here in this function you can mass at LRU cache LRU cache max size is equal to none. Let's try to run this again. It's passing as well. Okay, awesome, it's passing as well. So what will be the time complexity now? So time complexity for this approach, you can say approach 1, and time complexity would be earlier it was brute force, you can say. Okay, so time complexity will be O of n into s. S is the total sum. Okay, so S is the total sum. So here S is equal to total sum. Okay, and space complexity would be O of n into S, where S is equal to total sum. Okay, but we are also using the auxiliary stack space over here, so it be still be using the auxiliary stack space, so it is O of n. So O of n into S plus O of n. Okay.